So this video will be an introduction to data analysis and visualization with Python. So as part of this, we will first take a look at NumPy, which is a linear algebra library, and many data science libraries are built on top of NumPy. So it's good to know some basics of NumPy library. Next we will take a look at Pandas library, which is one of the most popular library used for the analysis of data which is in tabular format. Finally, we will learn some data visualization techniques using one of the oldest and most popular data visualization library for Python, which is called as Matplotlib. So let's start with NumPy. So NumPy stands for Numerical Python. It is a linear algebra library. It is used to work with multidimensional array objects. Most data science libraries in Python are built on top of NumPy. So NumPy objects are homogeneous multidimensional arrays. So let's import NumPy by writing import NumPy as np. So let's try to define a one-dimensional array using NumPy arrays. So I'll say a equal to np dot array, and let me create an array. Okay. So when I execute this and check, so it is an array which has 4 numbers 1, 2, 3, 4. As informed earlier, NumPy can store multi-dimensional objects. So let's define a two-dimensional array. So a two-dimensional array is basically called as a matrix, right? For example, if you want to define a matrix with two rows and two columns. Okay, we'll define 1, 2, 3, 4, 5, 6. So we'll define something like this which has 2 rows and 3 columns. So you can define this matrix, which is a two-dimensional matrix, using NumPy arrays. Okay, so let me write a is equal to np dot array, and this is how you define it. So you have an outer square braces, and inside that you can have 2 rows and 3 columns. So the values are 1, 2, 3 in the first row and 4, 5, 6 in the second row. Okay, so let me execute this, and you can see that we have created an array which is of the size 2 rows and 3 columns. NumPy arrays have a built-in function called as shape, which will help you to check what is the number of rows and the number of columns that our array has. So when I say a.shape, we have 2 rows and 3 columns, so we'll get 2, 3. There is also a built-in function called as ndim, which will actually display the dimension which the array has. Okay, in our case it is a two-dimensional array, so we'll get the dimension as 2. We can also declare 3-dimensional arrays in NumPy, but let's not complicate things for now and keep it simple for this introductory video. A built-in function called as arrange will help you to generate an arrays which is less than a given number. For example, if I say np.arrange of 10, it is going to generate the numbers from sequence of numbers from 0 to 9. So when I execute this and check the value of a, you can see it is an array of numbers from 0 to 9. And you can check the length of the array using size function. So it will basically give you the number of elements that you have in your array. If you want to generate a a sequence of zeros, okay, you can make use of this built-in function called as zeros. And if I pass 5, so it's going to generate 5 zeros. Okay, so it is going to generate 5 zeros. You can also generate a sequence of matrix, I mean a matrix of zeros. So what I'm trying to say is, so if I want to create a matrix of zeros, for example 2 rows and 3 columns, so I want to create a matrix, something which looks like this, an array, or sorry, a matrix of zeros. Okay, so let me create this using np.zeros, and we have to pass the number of rows that we want and the number of columns that we want. So this will generate a matrix of zeros. You can similarly generate a matrix of ones as well. So instead of zeros, you just have to write ones and it will generate a matrix of ones. Okay, so let me define two arrays here and perform some basic operations on NumPy arrays, such as addition, multiplication, and subtraction. So let me define two arrays here, np.array, and let's have 10, 20, 30, 40. Okay, and b np.array. Okay, it's having 2, 4, 6 and 8. So I have two arrays here. So if you want to add these two elements to these two arrays together, you can write a plus b, and it will do an element by element addition. So the resultant will be 10 plus 2 will be 12, so that is what you get in the first element, and 20 plus 4 is 24. So it does an element by element addition. So similarly you can multiply, so you can perform the subtraction. So a minus b, it will 10 minus 2 is 8 and 40 minus 8 is 32. So that is what you get in the last item. So we can also use star operator to multiply both the elements together. So this is again an element by element multiplication. When you do this, you get 10 into 2 is equal to 20, 20 into 4 is equal to 8, and 30 into 6 is equal to 180, and finally 40 into 8 is 320. So you get element wise multiplication. So if you want to multiply all the items with a constant number, for example if you want to multiply all the elements with 2, then you can write b star 2. So it will multiply each item with 2. Okay, now let's try declaring two matrices and multiply them. Okay, so let me define the matrices something like matrix A will be 1, 2, 3, 4, and let me have a matrix B which is having ones. So if you want to do element wise multiplication, what is the element wise multiplication? So 1 into 1 is 1, 2 into 1 is 1, 3 into 1 is 3, 4 into 1 is 4. So if you want a multiplication like this, so you can simply write A star B. So let me define the matrix first. np.array. So we have two rows, 1, 2, 3, 4, and b equal to np.array 1, 1, 1, 1. Okay, so when I say A star B, so you will get the element wise multiplication, which is 1. Sorry, this is 2 into 1 is 2, right? So you get 1, 2, 3 and 4. So if you want to get the dot product, so what is dot product? Let me just demonstrate. Let me define the matrix again, 1, 2, 3, 4, and then you have 1 1 1 1. So what is the dot product of these two matrices? So you first start with the first row of first matrix, 1 into 1 plus 2 into 1. So what is 1 into 1 plus 2 into 1? It is 1 plus 2, and then 1 into 1 plus 2 into 1 again. The first row, first column, first row, second column. It's again 1 plus 2. Second row, first column. So 3 into 1 plus 4 into 1, it is 3 plus 4. And again second row, second column, which is 3 into 1 plus 4 into 1. So which is basically equal to 3 3 7 and 7. So this is the dot product of these two numbers. So if you want to get the dot product of two matrices, so you can simply write at the rate symbol b, a at b. So you'll get the dot product. Okay. So also the thing that you have to remember is that when you're multiplying two numbers, two matrices, then make sure that the length the length matches. For example, if A is of size 5, sorry, if it is having 3 rows and B is having 2 rows and you're trying to do element wise multiplication, you will get a value error because both of them are not having, or the size of both of these matrices do not match. Okay. So I'm defining a matrix here. So if you want to find the sum of all the elements in your matrix, so 1 plus 2 plus 3 plus 4. So if you want to find that number, you have a built-in function called sum that you can apply on the matrix, and you'll get the sum of all the elements that are present in your matrix. And if you want to find out the maximum item that is present in your matrix, you can use max. To find the minimum, you can do a dot min. Okay. So now let's see something called as stacking of arrays. So let's assume we have a matrix. For example, we have two matrix 1 2 3 3 4 5. So we have a matrix here like this, and one more matrix 9 8 7 and 6 4 5. We have two matrices. So the stacking of these two matrices will result in a bigger matrix, which will have values something like, it will have all the values of first matrix, and below that it will have the values of second matrix. Okay. So this is what is called as stacking. It's basically appending one matrix over the other matrix. Okay. So let's perform this stacking operation using NumPy built-in function. So let me first define these two matrices. A equal to np dot array of 1 2 3 4 5 6. Okay, and then we have B, which has the values, for example, say 9 8 7 6 4 5, and this is supposed to be 3 4 5. So let's see the same example. So when I say a dot, there's something called stack. Sorry, it is np dot vstack, and you can pass the two matrices A and B. So you have to pass it in between the parentheses, and when you do that, you'll get a single matrix with all the items stacked over each other. Okay, so that was about NumPy. Now let's move on to Pandas. Pandas is an open source data analysis library for Python. Pandas has two main data structures, and they are series, which are one-dimensional, and data frame, which is two-dimensional. So let's start by importing Pandas as PD. So Pandas series is just like Python list, but series is associated with the index, or you can customize the indexes that the series has. Okay, so let me define one series here, pd dot series, and I'll pass a list of numbers. Okay, and then when I say print, so you can see that each of the element has an associated index, and you can also customize the index. You can have any index that you need. So let me try to provide a custom index by creating another series. I'll say pd dot series. This time I will pass an index or a dictionary. So I want to make the key as the indexes and the value as the actual value of the series. B is 2 and C is 3. Okay, so now you can see that indexes of the series is nothing but the keys of the dictionary, and the values have become the actual elements. Now let's move on to data frames, which is the most popular used data type in Pandas. Pandas data frame is a two-dimensional labeled data type, or data which has columns and rows. Columns can have different data types. Okay, let's try to import data from a CSV. You can basically get the data from variety of sources. So I have a Excel file here, or a CSV file, so you can get data from CSVs, Excel or databases onto your data frame or Pandas data frame. So I have data here about it is called as iris data. So it basically has 5 columns: sepal length, sepal width, petal length, petal width, and the species of basically species of different species of flowers and their respective sepal length, sepal width, petal length, and petal width. So let's import this data onto our data frame and try to do some analysis using Pandas. Okay, so to import data, you just have to write pd dot data. You have a method called read CSV. You just have to pass the name of the file, iris.csv. This is the name of our file. So we have imported the data into this iris. So this is actually the type of data frame. If you check type of iris, it is a data frame or a Pandas data frame. So if you want to display the first 5 rows, you can simply type iris.head. So this will basically display the first 5 rows of our data set. And if you want to display the first 10 rows, you can pass it here as an argument, and it will display the first 10 rows. And if you want to display the last 5 rows, instead of head you can write tail, and it will display the last 5 rows. So data can be imported from variety of data sources, as I already mentioned, like Excel, CSV, MySQL, or Microsoft SQL, or variety of data sources onto your data frame or the Pandas data frame. Now let's try creating the data frame using dictionaries. Okay, so I have a dictionary here. Let me define a dictionary. So the first column, let me have name. Okay, so the name will be A, B and C, and the second column, let's have height, and height 20, 30, 40. Okay, and then we have weight, $50, $60 and $70. So we have a dictionary here. If you want to convert this dictionary into a data frame, you can simply write df1 equal to pd.dataframe, and inside that just pass your dictionary, and this will convert your dictionary into a data frame with rows and columns. Okay, so now let's go back to the iris data frame. So if you want to display all the column names that you have in your data frame, there's a built-in function called as iris.columns, or an attribute. So it will display all the columns that are present in your data frame. Okay, and then if you want to display the average value of a particular column, for example, we have sepal length. What is the average value of all the items that are, all the numbers that are present in sepal length? So in Excel, if you just try to calculate, the average comes to around 5.83. so if you can observe here, so the average says it is 5.84. okay, so if you want to find out that using the pandas, you can simply write iris dot sepal length dot mean, and this will return the mean value or the average value of the column. You can also write the column or refer the column name as in between the square braces. Sepal length dot mean. So this will also provide the same result. Okay, and if you want to find out what is the maximum item or the maximum number that is present in this column, you have a built-in function called max. So this will return the maximum number that is present in this column. Similarly, if you want to get the minimum, the built-in function is .min, column name .min. Okay, but if you want to find out the values of other columns for an item which has the minimum or the maximum sepal length, for example, you have this. So what is the value of other columns for this particular row? So you can write iris.loc, okay, iris of sepal length, okay, dot id x max. So when you execute this, you will get the value of other columns for which the sepal length is maximum. Okay, so if you want to create another data frame by selecting the data or by selecting columns of, or so if you want to select only certain columns and create a new data frame, you can simply write pd.dataframe, and we are going to use this as a source iris, and the columns that we want to extract is equal to So let's extract only 3 columns: sepal length, sepal width, and species. So this will create a new data frame with only 3 columns: sepal length, sepal width, and species. And if you want to delete a particular column from your data frame, you can simply write df2 equal to data frame 2 dot, you have a method called drop, and then you can pass the column name that you want to drop. So if in my case I want to drop sepal length, and then there's another parameter called this will be either 1 or 0. So 1 means that you're trying to delete a column, and if you pass 0, then it will delete a row. Okay, so in this case I am passing 1, which means it will delete the entire column. So after deleting, let me check the value, and you can see that it has deleted the first column, which is the sepal length. Okay, but then if you want to drop for example the 5th or the 3rd row, you should write 0 here, which means you're trying to delete a row. So you can observe that we have deleted the row which is having the index 3. So let's also try to delete a row which is having the index equal to maybe 2. So you know that you can see that it has deleted 2 and 3. Okay, so this is how you can delete a particular column or a row. Okay, now let's move on to the data visualization part using Matplotlib. So to make use of Matplotlib, let's import it. Import matplotlib.pyplot as plt. So pyplot is our plotting library from Matplotlib, and then I have to write something called matplotlib %matplotlib inline. So %matplotlib inline is something that is specifically used when displaying charts in Jupyter Notebook. So when you are using some other IDE, you don't have to write this. Especially when you are displaying charts in the Jupyter Notebook, you have to write this line %matplotlib inline, so that you can display the charts in the Jupyter Notebook. Okay, so let me import the module. Okay, so at first let's try to display a scatter plot or a scatter chart in Matplotlib. So what is a scatter chart? So we have some data here. So in the x-axis we have data 1, 2, 3, 4, 5, 6, and in the y we have 10, 20, 30, 40, 50, 60. So this is what is scatter plot. So for each value, so for example 1 and 10, x-axis is 1 and y-axis it is 10. So we got a point here. So this is the first point, and the second point, x is 2 and y is 20, 2 and 20. So similarly we plot other points. So when you plot an intersection of x and y, it will be basically a point. So this is nothing but the scatter plot. So let's try plotting or doing the scatter plot in Python or using the Matplotlib. So I'll define x values. Okay, and then let me define the y values, 10, 20, 30. Okay, Okay, we have the values of x and the values of y, and if you want to simply create a scatter plot, it's just one line. You just write plt.scatter and just pass the values x and y, and it's going to create a beautiful scatter plot using the data. Okay, so in the next example we want to display the values as well. You can see that we have the values along with the points, so that we don't have to refer back the points here, I mean the values here. So we want to display the values beside the point itself. So if you want to do this, there's a way to do that, but it's a bit tricky, so let's try to do that. So I'll write figure comma axis equal to plt dot, so we'll make use of the subplots. Okay, for I comma j in zip of x comma y, so we'll take both the values. For in each iteration we are taking one element from x and one element from y, and we are going to annotate on the graph. So x annotate, so we'll write the value of x, we'll say percentage s. So what goes here is the I or the x value, and the coordinate that you want to write this will be I and j. Okay, so what this will do is it will write this part, opening the parenthesis and write the x value and then write the comma. Now in the second line, let's try to annotate the value of y. So you have to write percentage s and close the parenthesis. So you have to write the y value. Okay, then something called xy text equal to 25 comma 0. Then we have to write text coordinates equal to offset points. Okay, now we'll say plt dot scatter x comma y. So now we can see that we have plotted the values along with. So this particular code or line is responsible for writing the x values, and this code is responsible for writing the y values. Okay, so if you want to plot the line as well, okay, so that you can see the trend, let's try to plot the line as well. So let's copy the entire thing and paste. So you just have to write one more line here. So plt dot plot x comma y, and we'll give a line width equal to 1. So this will basically plot the line as well. Okay, so similarly you can have multiple options. So let me define the points here, and if you want to plot x comma y, if you want to plot blue circles or blue dots, you can write this BO. Okay, and if you want to plot for example red color plus marks and marker size, sorry, so this will plot the plus red marks. And then if you want to plot more than one values together, so y2 equal to 20, 40, 60, 80, 100. Okay, so I want to plot x comma y in green triangle, and x comma y2 in blue color square. So we need to have one more. Okay, so you can plot multiple types of plots or points together. So let's try to draw this sine wave using Matplotlib. So let me define the x-axis or the time. np.arrange. So it's going to start from 0.0 to 2.0. Okay, so the value will start from 0.0 to 2.0, and then let it increment with 0.01. so I'm generating the value of x, and in the value of y I am generating a sine wave, which is nothing but 2 star pi 2 pi into the value at x. So we have the value of x-axis, and in the value of y-axis we have the sine wave. So let's plot it. plt.plot the x and y-axis. Okay. Sorry. Okay, so if you want to plot the labels, the x labels and y labels as well, so you can write plt.x label. So in the x-axis we are displaying the time. Okay, so it appears here, time, and in the y-axis we are displaying the voltage in millivolt. Okay, so this is how you write x and y-axis labels. Okay, now let's see how to draw subplots. What is subplots? If you want to, in one single graph, if you want to display two graphs, in one plot you want to display two graphs, then you can make use of this subplots. So let's try displaying the graph 1, chart 1 and chart 2 in the single chart. Okay, so let me just copy this. So let's keep x from 0 to 5.0 with increment 0.1, and let's have y1 equal to np.sine. Okay, and let's keep y2 equal to in the first plot, let's plot damped oscillation. So we just have to multiply with exponential of minus x, and in the second plot we are plotting the undamped oscillations. Okay, so we'll say plt dot subplot. So basically we need 2 rows and 1 column. Okay, so this figure will become 2 rows, 1 column and first graph. So this the code for this one will be second of 2 rows, 1 column and second graph. Okay, just remember this, the code for this graph is 211 and code for this graph will be 212. So I have to write I'll plot the first graph, plt dot subplot 2, 1, 1. So we are trying to plot this first graph 2, 1, 1, and in the first graph we'll plot x, y1. Okay, and in second graph, which is 2, 1, 2, we will plot x and y2. Name P. Okay, so we have plotted both the graphs, both the plots in one graph. So what if you want to plot 4 graphs at once? Okay, something like this. So in this case we have 2 rows, 2 columns to get a total of 4 graphs. So this one will be 2, 2, 1. So this graph, it will be 2, 2, 2, and this one will be 2, 2, 3, and this one finally will be 2, 2, 4. So let's try quickly doing that. Let's plot the same graphs here. Let's replicate it instead of trying it again. So 2, 2, 1, 2, 2, 2, 2 and 3, 2, 2 and 4. So in this case we have generated 4 plots in one graph. Okay, so next let's move on to this something called as bar chart. So in the x-axis we have the countries, China, India, US, Indonesia and Brazil, and in the y-axis we have the population. So China is having population of 23, which is the largest, and then we have the Brazil, which is the population of 6, which is the least. So let's try to plot this graph using Matplotlib. So let's create this data first. So we have country equal to, so we have China, India, US, Indonesia and Brazil. China, India, US, Indonesia and finally Brazil. And then the population, we have 23, 15, 10, 8, 6. 23, 15, 10, 8 and 6. Okay, so you cannot directly plot the text here on the x-axis. Okay, so let's try plotting that. So first we get the indexes, right? np.arrange. First we'll try to plot in the x-axis. First let us plot the indexes 0, 1, 2 and 3, and then later on we'll replace the indexes with the text, I mean the country names. So that first we are trying to get the index, np.arrange length of country. Okay, so if we check index, it will be 0, 1, 2, 3, 4. For each of the country we are generating an index 0, 1, 2 and 3. Okay, now let me plot the bar graph, plt.bar. In the x-axis we are plotting the index, and in the y-axis we are plotting the population, and we have to write align equal to center alpha equal to 0.5. This is basically the intensity of the color, okay, alpha. And then we have to replace the indexes with the text, right, with the country names. To do that, we write this line. So let's execute this. Okay, alpha. So we have created a bar chart. So if you want to remove these messages, just type plt.show. Okay, so it will remove those messages. So we have plotted a bar chart. Okay, next let us move on to creating something called as horizontal bar chart. It's just the same thing but plotted in horizontal way. Means the countries are plotted in y-axis instead of x-axis, and the population is plotted on the x-axis. So let me copy this and paste, and in this case instead of bar we'll write horizontal bar chart. So in the x-axis not x-axis, when you say horizontal bar chart you write the index and then the population align equal to center. Everything remains the same, and only thing that changes is instead of x ticks it will be in the y ticks, index to country. So it's just one change, and x ticks to y ticks, you can plot the horizontal bar chart. Okay, so next let us look into something called as stacked bar chart. So this is called a stacked bar chart. So what is happening is we are comparing the population of both male and female together for each country. In China, if you observe, the population of male is 13 and population of female is 15. And in Indonesia, the population of male is 9, which you can observe here as well, and the population of female is 8, which you can observe here as well. So let's try to plot this using Matplotlib. So let's create this data first. Okay, let me copy this data. So I'll say population male equal to this thing, and population female equal to 21, 18, 6, 9, 9. Okay, so I'll define data something like this. Now let me get the index first, right? We need to get index. So np.arrange will say length of country, so it will define indexes for each of these countries 0, 1, 2, 3 and 4, and then let me define something called as bar width. So bar width equal to 0.35. okay, now first thing I'll plot the population of male. Okay, so I'll plot index and the population of male, and this will be our bar width, and alpha equal to 0.8. color will be blue color, and then label will be male. So let's copy the same thing. Okay, so this time it will be a population of female, and you have to plot it with index plus bar width. Okay, so if index of male starts from here, the index of female will start after this bar width. Okay, so index of male plus the bar width will where the index or the bar of female should start. Okay, so that's why we've written index plus bar width. And then the color will be green, and label will be female. Okay, so we got this. So only thing that we want to do is we want to replace this with the country names. So we'll say plt dot x label will be plt dot x ticks index plus bar width, will replace it with country, and then we have to plot the legend as well so that we can display this information. So which color is male and which color is female will display. This plt dot legend will display that. Okay, now let's move on to something called as pie chart. So we have the population here. So with the pie chart you can see the percentage. So China has the maximum population, that's why it is 37%, and you can see it lot of space being occupied with China. And the second one is India, so it is having 15, which comes to around 24.2%, and then you have the rest of the countries. So let's try to plot this pie chart using Matplotlib. Okay, so let me define the country and population again, and if you want to plot the pie chart you just have to write plt.pie, and I want to write the population. Labels will be the country, and we want to calculate the percentage. To calculate the percentage you have to write like this, auto PCT, and the format will be 1.1f. So you get the floating point or the decimal point as well. And then we'll write shadow equal to true, and start angle equal to 90. Okay, and we'll also plot. You have to write plot.axis as equal, so that sometimes it looks like an elliptical, the pie chart. To make it circular, we write plot.axis equal. So let's just verify that. If we don't write, let's see what happens. So I don't think it doesn't make much of a difference. Okay, so this is how you plot a pie chart. Finally, we have something called donut chart. So donut chart is just like pie chart. There is no difference at all between the pie chart and donut chart. Only thing that is, in donut chart this middle portion will be removed, okay, and to make it look like a donut. That's the only difference. So the middle portion will be removed and it will be colored with white, right, to make it look like a donut. So let's try to create this donut chart using Matplotlib. So let's copy the entire thing. So the idea is to create a circle with white color and place it in the center of this pie chart to make it look like donut. Okay. So let's plot the pie chart, and then now let's create a center circle. Center circle will be plt dot, will plot circle, will plot circle 0, we'll start with 0, 0, and the radius will keep it as 0.7, and color equal to black. This is the outline color, and the fill color will be white, and we'll say line width equal to 0 so that the outline black color is not visible, and fig comma plt dot gcf, and then to place that circle in the center of the chart you have to write figure dot gca dot add artist center circle. Okay, zero comma 0, 0.7, color equal to black. Okay, line width okay. So this is how we create a donut chart. So this particular line, these three lines will create this circle with white color, white fill color, and it will place in the center of the pie chart just to make it look like a donut chart. Okay, so that's it for the introductory course on data analysis and visualization using Python libraries.